Okay, lesson 31C, day 2 of graphing linear equations. I'm just going to continue what we started yesterday. So just to review a little bit, linear equations, what we introduced yesterday, that is an equation where the solutions, which are all the dots on the line, form a straight line. Anything that's not on the line is not a solution. A solution is the ordered pair x comma y that makes the equation a true statement. So yesterday we talked about, is this ordered pair a solution? And what you did was just plug it in. And if it made a true statement, it was a solution. If it's not a true statement, it's not a solution. If it's not a solution and you tried to plot it on the graph, it would just not be on the line. It'd be like a random dot floating off to the side. Okay? All good? So yesterday we graphed, we found 3 points to make a line. If you only have 2 points, it's just not accurate enough because the third one might be off and it wouldn't be a straight line. And 1 point is just a dot that doesn't make a line. So you need at least 3 to draw a line through it. So let's go ahead and get started. Number 1, we are going to practice graphing lines. So what I'm going to do is give you the 3 ordered pairs. So if the first one is 2, 0, go ahead and plug it in to make sure that it is a solution, just like we did yesterday. 3 times 2 is 6, plus 2 times 0 is 0. What's 6 plus 0? 6. So is 6 equals 6? Is that a solution? Yeah, that works out. So that is an ordered pair that is a solution to this equation. Check to see if this ordered pair works. 0, 3. 3 times 0 is 0, plus 2 times 3 is 6. What's 0 plus 6? 6, which is what we wanted, so that one works too. 4, negative 3. 3 times 4 is positive 12. And then plus 2 times negative 3, which is negative 6. 12 minus 6 is 6. 6 equals 6. So that also works. So go ahead and plot these 3 points. 2, 0 would be right there. 0, 3 would be right here. And 4, negative 3 means go to the right 4 and then down 3. It should line up quite nicely. Do your best to draw a line straight through all of them, and do put arrowheads at the ends of your line. I would also like you to start practicing labeling your line. I like to write them on the side of the line right here, so it's very obvious that this is the line I'm talking about. And the reason why we want to label our lines is when we start graphing multiple lines on the same coordinate plane, you need to know which one's which. So if you don't like writing sideways, you can always write it normally and just draw an arrow pointing to it. But like I said, if we start drawing multiple lines on that graph and you're drawing arrows to point to them, there's just too many arrows, so it's kind of messy. But since there's only one right now, that's okay. Number 2, do these ordered pairs work as solutions? 4, 0. Does that work? That'll be 8 plus 0 equals 8. Yeah, that works. How about 0, 2? That'll be 0 plus 8 equals 8. Yep, that works. How about negative 2, 3? Two times negative 2 is negative 4, plus 8. Not plus 8, plus 12 equals 8. Yep, that works. So you can go ahead and plot those 3 and make your line. Also label it. I didn't have to pick those 3 ordered pairs, right? No. I just made them up. Check to see if they worked. There's plenty of other points I could have picked because remember I talked about yesterday, a line is made up of all of the solutions that could possibly work to plug into this equation and get a true statement. So there's so many dots on this line that it actually looks like a solid line, but it's really made up of all of those little dots. So looking at this line, can you tell me another solution? What's another ordered pair that is on that line? 8, negative 2 is right here. That would work. Noah?
Negative 8, 6.
Negative 8, 6 is right here. That works. Anything else? Mm-hmm.
Oh, -6, 5.
-6, 5. That looks like it works. Anyone else? Adrian? -4, 4 looks like it works as well. Go ahead.
2, 1.
2, 1 looks like it works. Mm-hmm. Yep.
1, 6.
1, 6 is here.
6, -1.
6, -1. Alright, those looks like we covered all of the easy to read ones. Now remember, these are actually also points that are in between here. Like this is a point, that's a point, that's a point, that's a point. It's just really hard to like tell me what number it is because it's not exactly crossing a grid, right? So, but those are also points. The answers to those x and y's will be your ordered pair will be fractions. We just try to stay away from them. When you can read easy points, go ahead and read the easy points. You don't have to go the fraction route. Okay, looking at number 3. This time I'm going to give you just the first part of the ordered pair. I want you to tell me what the second number is going to be. So if I say that the x here is 1, how do I know what y has to be? You're going to plug it in. 5 times 1 minus something has to equal 5. 5 times 1 is 5. 5 minus what is going to give me 5? What is it? 0. So that means y has to be 0. So my ordered pair is 1, 0. Alright? So here's another one. If the second ordered pair starts with 0, so I plug it in, 5 times 0 minus something has to equal 5. What would that have to be? Noah?
5 times 2 is minus, or it would be,
5 times 0 is 0. Minus something has to be positive 5. -5, yes. -5, because negative 5 would make positive 5. So my y would have to be -5. See that? Here's my third ordered pair. Let's see what happens if I plug in 2. So 5 times 2 minus something has to equal 5. 10 minus something has to be 5. Yep, this one would have to be positive 5. So now I have my 3 ordered pairs. Go ahead and plot them. Make sure they line up. And draw your line through it. And don't forget to label it. What other ordered pairs lie on this line? Andrew. Say it again. 2, 5. 2, 5's already there. That one is a solution. What's another ordered pair? 3, 10 would be right here. Yeah, that would work. If I plugged in 3, that would be 15. 15 minus 10 would be 5. That works. What's another one? How about the one on this end of the line? What would that be? Yes, Celine. -1, -10. This one right here. That would work. Very good. And I believe those are all the ones that are easy to read, right? The rest of them kind of cross through in between the boxes, so those would be fractions, which is just too hard to guess what they are. So let's move on to number 4. Again, I'm going to give you the first part of the ordered pair, and you tell me what the second number should be. First one is -2. So plugging that in, -3 times -2 plus 2 times something has to be 6. So that'll be 6 plus something equals 6. Yes.
2 times 0.
2 times 0 would give me 6. Awesome. So the first one is -2, 0. Because it gives me 6 equals 6. The next one, let's see what happens at 0. Aiden? 3 is correct. That will be 2 times something equals 6, so that will be 3. Very good. And then the third one, let's see what happens at positive 2. Negative 3 times 2 is negative 6, plus something has to equal positive 6. Yeah, 6. Very good. This will be 2 comma 6. Because negative 6 plus 12 gives me 6. Go ahead and plot it, draw your graph, and label it. So tell me some other ordered pairs on this line. Go ahead. Negative 4, negative 3. Yep, that would work. Having trouble? 3, 8. That one does not quite meet on the line, and let me tell you why. Notice, let's look at this one to this one, that green one to that green one. If I count over 2, up 3, I get to the next one. If I go over 2, up 3, it's this one right here. So this one is a little bit off. So this one would be 1. I can also go down 3 over 2, down 3 over 2, down 3 over 2, and I got to this one. Can I go down 3 over 2 again? Yeah. Tell me the ordered pair for that. Start from here. Go down 3 over 2. Right here would be negative 6, negative 6. Remember what this is called? It starts with an S. Slope. Good, slope. When you count, when we can count on the grid, that is a slope. Each solution lies on the same slope. Alrighty? Let's go on to number 5. Now, some of you might be wondering, how are you coming up with these numbers? How do you know what the first one's going to be? Really, you can pick any number you want. Stick with easy numbers so that you can multiply them easily. And you do have to do a little bit of critical thinking. So let's say here I wanted to pick this one's not a good example. I'll talk about it on the next problem. But you can pick any number. It's just that your second number might be a fraction because remember your line does go through some like spaces and doesn't always go through a grid. So your second number might be a fraction if your number just didn't work out very pretty. So just always pick easy numbers. If it doesn't work, just pick like an odd number or an even number depending on the problem. So here I'm going to go ahead and give you the first number again. Number 5. Let's pick 0. What would the other number have to be? If x is 0, y would have to be not 8 because this is subtraction. It has to be negative 8. Go ahead.
Negative 3, 4.
Negative 3. So that would be negative 4 times negative 3 is 12. Minus 4 is 8. Yeah, that works. Good. How about negative 2?
0.
Negative 2, 0. How about, let's do one more. Negative 1. Negative 1 would give me 4 minus something has to be 8.
Negative 4.
Negative 4. Awesome. So we got 4 of them now. Go ahead and plot them. Label it so we know what line you drew. And tell me what are some other ordered pairs that lie on this line. Negative 4, 9. Looks like that one would work. Let's test it with the math. Negative 4 times, oops, let me write it over there. Negative 4 times negative 4 minus 9. Is that 8? 16 minus 9? Nope, that does not work. So that one doesn't work. It looks like it does on the graph, but it's a little bit off. Especially with your pencil line, it's going to be really hard to just rely on that, so you do want to check your ordered pairs. Negative 4, negative 8, you said? Negative 4, negative 8 would be here. Floating off the line. Negative 4, positive 8. Right here. Plug it in and see. Negative 4 times negative 4 minus negative 8. 16 plus 8. I mean, this is positive 8. 16 minus 8. Yeah, that works. Very good. Aiden? Negative 6, 16. That goes off my grid, but if it works in the math, that would be good. Negative 4. Wait, what did you say? Negative 6, 16. So 24 minus 16. Okay. All right, let's move on to the next one. Number 6. Last one. See if you can come up with ordered pairs on your own. See here, this is a good one to talk about. If I pick my x to be 1, let's say I want it to be 1. This will be 3 minus something has to be 8. What would that have to be? 3 minus what is 8? That would be 5. Can 2 times anything give me 5 easily? No, it would be a fraction, right? So we see that 1's not going to work, which is an odd number, because odd number minus even, this would be even, is never going to give me 8. So you want to maybe change the 1 to an even number. Maybe try 2. See where it takes a little bit of critical thinking? You're not really just picking any number. I mean, it would work. Your y is just going to be a fraction, which is still a solution, but it's just not pretty.
You can do 4, 2.
4, 2? Let's try that. 3 times 4 minus 2 times 2. 12 minus 4. That works. 4, 2 would work. So that's one of them. Got another one? 2, negative 1. So 3 times 2 minus 2 times negative 1. That would be 6 plus 2. Yep, that works. Very nice. What's the easiest number you can pick? 0. Let's try that one. 3 times 0 minus 2 times something has to be 8. Negative 4. Awesome. Alright, so I won't be there for your homework to give you the first numbers. You have to pick your own numbers. Try to keep them small and easy. But, for example, this problem, odd numbers wouldn't work for x. It would give you a fraction for y, which is a solution. It would fit on the line, but when you graph it, who wants to graph fractions, right? That's just really inaccurate to graph. So we see that 1, which is an odd number, doesn't work because 2 times something is never going to give us an odd number. So stick with even numbers. All right? Also, another trick you can think of is if 2 works, see if negative 2 works. Because remember we did our counting the slope? If we can go over 2 up 3, can we go over 2 down 3? Right? You can go both ways counting on your line. So if 2 works, negative 2 probably works too. If 4 works, negative 4 probably works too. Yeah? So that's how you can get your 3 ordered pairs more quickly. This is what this graph should look like. Any questions? Pretty cool? All right, what'd you learn today then? Ready? Share.